Chapter 3, Section 2 is about the angles formed by parallel lines and transversals. So by the end of this lesson, you should be able to prove and use theorems about the angles formed by parallel lines and transversals. So we already talked a little bit about what happens when a transversal cuts through two lines, but now those two lines are going to be parallel, and that changes everything. So if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. And this is a postulate, and remember that's something that we don't need to prove, we can just accept as true. So like angle 1 and angle 3, those are corresponding and those are congruent. And then angle 6 and angle 8, those are corresponding, so those are congruent. But then remember, we also know that vertical angles are congruent. So 1 has to be congruent to 6, and 3 has to be congruent to 8. And then the same kind of thing works for the ones that they did in blue here. 5 and 7 are corresponding, and 2 and 4 are corresponding. But then remember that 4 and 7 are vertical and 5 and 2 are vertical. So we end up with basically only two options for angles here, which will come in very handy in the next couple sections. So let's use that and find each angle measure. So the first one they tell us to find is the measure of ECF. So E to C to F. This guy right here is what we want to find. So the first thing we got to notice when we're looking at something like this is these little arrows here. And I know they seem itty-bitty, but they are very important. They're telling us that those two lines, like AG and DF, are parallel to each other. And because they're parallel, we can use this postulate here, which says that the pairs of corresponding angles have to be congruent. So corresponding angles, this angle right here corresponds to this angle right here. And if you look, I know this is 70 degrees, so that means this also has to be 70 degrees. Now the next one they want us to find is DCE. So here, here, here. And we can do a couple things with this. We're going to use the corresponding angles theorem, which I know is more work than something else. But I know that this angle here has to be exactly the same as that angle there. So I can make a nice little algebra equation that 4x plus 22 has to be exactly the same as 5x. And then I can solve for this. Minus 4, minus 4. So I end up with 22 equals x. And then I could plug that back in. 5 times 22 will give me 110. So that means this angle right here has to be 110 degrees. Now hopefully your brain was working and you thought to yourself, well, geez, oh Pete's, this is a line right here. So if this guy's 70, this guy has to make up the rest of the 180 degrees. So 180 minus 70 will also give us 110. So there's tons of different ways to do these problems if you remember all of the different postulates that we know. So here's three more. Alternate interior angles, alternate exterior angles, and same side interior angles. So all the ones that we talked about yesterday. But basically, when you have a parallel line, that makes a lot of things congruent. And our alternate interior angles are congruent, our alternate exterior angles are congruent, and then our same side interior angles are supplementary. So we know that 4 plus 1 has to add up to 180. And the same thing the other way around. 3 plus 2 has to add up to 180. And then remember that 1 and 3 have to be the same, and 4 and 2 have to be the same. So let's prove one of these theorems. I know we haven't done proofs since chapter 2, but we will be reusing them throughout the first semester in geometry. So let's make a two-column proof. We have our statements, and then our reasons. So they give us that L is parallel to M, and we are supposed to prove that angle 2 is congruent to angle 3. So we have L is parallel to M. That's a given. So the next piece of information we can use, if I know L is parallel to M, I know that 1 and 2 have to be congruent. And that is the vertical angle theorem. So I know that angle 1 has to be congruent to angle 2. And then I also know that 1 and 3 have to be congruent. And that's one of the ones we just learned, 1 and 3. All the way back here. 1 and 3 are corresponding angles. They're both on the right side and they're both on top. So I know angle 1 and angle 3 are also congruent due to corresponding angle postulate. And then we can either say by the transitive property, or if you want, you could say by substitution. Remember, our goal is to prove that angle 2 is congruent to angle 3. So if I know angle 2 is congruent to angle 1, I could substitute that in, or you could use kind of like the law of syllogism. So I'm going to say substitution. And it's of congruence. Or you could say transitive property, it doesn't really matter. But based on what we know so far, we can prove that those alternate interior angles of 2 and 3 have to be congruent to each other. And we could actually prove all of these, but not today. So let's do an example. Find the measure of each angle. So what I like to do when I look at problems like this is take a look at what they're asking me to find, and then go back and look for any numbers that I know. So if you notice, some of these are in algebra terms. They're in terms of x. We're going to have to solve for x eventually, but take a look at what they want us to find. A wants us to find EDG, so this guy right here. And then the second one wants us to find BDG. So this one right here. So first of all, we know our two angles have to be supplementary because they add up to that line. They're a linear pair. So then I look at the information that they've given me. And I know that this right here is a 75-degree angle. So that means that this right here has to be a 75-degree angle. That's the vertical angle theorem. And then alternate interior angles tells me that this angle here has to be 75 degrees. And this angle here has to be 75 degrees. They're all the same. So right there, that answered one of my questions without doing any algebra. The purple one of EDG is 75 degrees. And then I can use one of my other theorems. This one right down here, same side interior angles, and I know that they have to be supplementary. So if this angle here is your 75 degrees, this one has to add up to 180. So if I do 180 minus 75, I'm going to end up with 105. And that would be the same as this one if they asked me, the same as this one if they asked me, and the same as that one. So my two angles are 105 degrees. You can do this problem a million different ways. If we erase all this junk that we have going on here, you could use some algebra and say, well, this angle here and this angle here are equal to each other. Set those two things equal, solve for x, plug them in. You could also say that this plus this has to add up to 180. So x plus x minus 30 equals 180 and solve that way. Or you could do the way we did it. There's seriously tons of different ways to solve each one of these problems. So we're at the end of the lesson. You should be able to prove theorems about angles. We did one example, and use theorems about the angles. Make sure you write down any questions you have, and we can go over them tomorrow in class. Have a good night.